Our solar system's core, the Sun, is where all of the light and heat that keep life on Earth possible comes from. It is also our closest star. Humanity has been captivated by this enormous, very hot ball of gas for millennia. We'll go into great depth about the top 10 amazing Sun facts in this post. Before starting, don't forget to like and subscribe to our channel for more future updates. So let's start. Number 1. The Sun's structure. With various zones delineated by temperature, density, and energy transfer systems, the Sun's structure resembles a layered onion. Around 15 million degrees Celsius, 27 million degrees Fahrenheit, and 250 billion times the atmospheric pressure on the surface of the Earth are the temperatures and pressures at the center of the universe. Nuclear fusion, more particularly the fusing of protons from hydrogen nuclei into helium nuclei, takes place in this core. Amazing amounts of energy are released during this process, mostly in the form of gamma rays. About 70% of the Sun's radial distance is covered by the radiative zone as it expands from the center. The primary means by which the energy produced in the core is transmitted in this area is via the absorption and re-emission of photons as they scatter across the dense plasma. The convective zone of the Sun, which reaches the solar surface, is located above the radiative zone. Similar to how boiling water convects heat, heat is transferred in this situation by the movement of hot plasma cells, also known as convection cells. These cells transport internal heat to the surface, where it is emitted as heat and visible light, giving the Sun its brightness. Number 2. The Sun's energy production. Nuclear fusion, especially the conversion of hydrogen into helium nuclei via a sequence of nuclear processes, powers the Sun's energy output. The proton-proton chain reaction, which controls this process, causes the energy to be released in accordance with Einstein's famous equation, E equals mc2, which states that mass is transformed into energy. About 4.3 million tons of mass are transformed into energy by the Sun every second, largely in the form of photons. Due to numerous interactions with other particles, it may take these photons hundreds to millions of years to leave the dense core. They are expelled into space as sunlight as soon as they reach the Sun's surface. Number 3. Sunspots and solar activity. In truth, colder and darker patches of the Sun's surface are known as sunspots. However, their coolness is only relative to the surrounding areas. They have a darker appearance because strong magnetic fields prevent heat from the core from rising. Sunspots may remain for a few days to a few weeks and range in size. The Sun undergoes an 11-year cycle known as the solar cycle that governs its activity, including the development of sunspots. Solar activity is at its highest point during this cycle, increasing the development of sunspots as well as solar flares and coronal mass ejections, CMEs. On the other hand, sunspots are less frequent during times of low solar activity, known as solar minimum. Number 4. Solar flares and coronal mass ejections, CMEs. Explosive energy bursts known as solar flares occur in the corona, or upper atmosphere, of the Sun. They happen when unexpectedly released magnetic energy from the Sun's atmosphere occurs. UV and X-ray radiation are among the many radiation types that solar flares release, and these radiation types may have a big impact on Earth's upper atmosphere. Even more potent occurrences are coronal mass ejections, CMEs. They entail the massive ejection of magnetic fields and plasma from the Sun's corona. CMEs may cause beautiful auroras and damage satellites, electrical grids, and communication networks when they are directed at Earth. Number 5. The solar wind. The solar wind is an endless stream of protons and electrons, which are charged particles, that emanates from the Sun in all directions. The magnetic field of the Sun is carried along with it, forming the heliosphere, a magnetic bubble that surrounds the solar system. The interstellar medium, which lies beyond the heliosphere, is where the solar wind interacts with the Milky Way galaxy's gas and dust. The heliosphere is shaped by the solar wind, which also affects space weather. When charged particles hit the Earth's upper atmosphere as a result of its interaction with the magnetosphere, auroral phenomena like the northern and southern lights, auroras, may result. Number 6. Solar variability and climate. On short durations, the Sun's energy output is very steady, but over longer timescales, there are some slight changes. These changes, which are connected to the solar cycle, have the potential to affect the climate on Earth. For instance, Earth went through a little ice age, with colder temperatures during the Maunder minimum, a period of very low solar activity from the late 1600s to the early 1700s. It's important to remember, however, that these solar changes pale in comparison to the impact of climate change that is predominantly caused by greenhouse gas emissions. To distinguish between natural and man-made climate trends, it is essential to comprehend the Sun's involvement in climate variability. Number 7. The Sun's size and mass. The Sun's enormous size and mass are essential to its function as the solar system's gravitational anchor. It makes up the overwhelming bulk of the solar system's overall mass, with a mass that is around 333,000 times greater than that of Earth. All of the planets, moons, asteroids, and comets are kept in orbit around the Sun by its gravitational force. Our solar system's main source of light and heat is the Sun, which has a diameter of around 1.4 million kilometers, 870,000 miles, making it able to emit a tremendous amount of energy into space. Number 8. The Sun's age. With regard to the lifetime of stars, the Sun is in its middle age. It originated from a massive molecular cloud of gas and dust around 4.6 billion years ago. It has spent the most of its existence in the main sequence, burning hydrogen, where it has stayed rather stable and converted hydrogen into helium. It is anticipated that this phase would last for another 5 billion years or more. The Sun ultimately turns into a red giant and engulfs the inner planets, including Earth, when it runs out of hydrogen fuel. After finally losing its outer layers, it will be left with a dense, Earth-sized white dwarf that is encircled by a stunning planetary nebula. Number 9. Solar eclipses. Solar eclipses are fascinating celestial occurrences that take place when the Moon moves in front of Earth and the Sun and casts a shadow over the Earth. Depending on how the Moon and Sun are aligned, there are several kinds of solar eclipses, such as complete, partial, and annular eclipses. The most mesmerizing eclipses are total solar eclipses, which for a short time entirely obscure the Sun's light and display the Sun's outer atmosphere, the corona, in all its splendor. These occurrences have captivated people's attention for millennia and have contributed to scientific inquiry, including the investigation of the Sun's outer atmosphere. Number 10. Solar exploration missions. Humanity has launched several missions in observatories specifically designed for studying the Sun in order to get intimate knowledge of it and collect priceless data. One such project, the NASA Parker Solar Probe, was launched in 2018 with the goal of traveling closer to the Sun than any other spacecraft before it. It has specialist equipment for measuring the magnetic fields in the Sun's corona and the characteristics of the solar wind. Continual monitoring of the Sun's activity is provided by space-based solar observatories like the Solar Dynamics Observatory, SDO, and the Solar and Heliospheric Observatory, SOHO, enabling scientists to better comprehend its behavior and its influence on the Earth. In conclusion, the Sun is a spectacular celestial body that is crucial to the functioning of our solar system and to the continuation of life on Earth. Research into its intricate structure, nuclear fusion-based energy generation, and dynamic behavior is ongoing. Comprehending the Sun is crucial for comprehending not just our planet but also the space environment and for solving the riddles of stars and the cosmos beyond. The Sun is an important subject of research for both scientists and astronomers because of its enormous energy production and impact on the solar system. This is it for today's video. What do you think of our video? Let us know in the comment section below. For more updates in the future, don't forget to like and subscribe to our channel. Thanks for watching.